Hello, I'm going to give some reviews about semiconductors. So first, I will talk about doping first. So look at these figures. You can see this part of figure. When materials make covalent band, we can see the 8 bonds each atoms, but some elements are different. So look at these elements. These elements make free electron left. So we call it donors. And otherwise, some elements make hole like this part. So we call this element called acceptor. And we can draw the energy band, and we can see the red line between the conductor band and valence band. This red line is called Fermi level. In case of intrinsic semiconductors, the Fermi level is located between the middle of the conductor band and valence band. But the case of donor, the Fermi level is close to conductor band. And in acceptor case, the Fermi level is close to valence band. So we can distinguish what is acceptor and donor by this energy band. And I want to explain one more thing, that how much closer to conductor band and valence band is depend on how much we doping the materials. So donors make n-type doping, and acceptor makes p-type doping. In class, we already learned how to draw the energy band of PN diode, and this part is on depletion area and has the electric field. And next, we learned about MOSCAP. The MOS is the first word of metal oxide semiconductor. Look at this figure. This part is metal and oxide and semiconductor. And this structure is kind of a capacitor. And this figure is about the amounts of capacitor depend on the gate voltage. The MOSFET operation is divided into 3 areas: accumulation, depletion, and inversion. This figure is that area: accumulation, depletion, and inversion. The accumulation area, if we apply the negative voltage in the gate, the holes will accumulate in this area because we apply the negative voltage, and the substrate is a p-type substrate. So its major carrier is the hole. So a lot of holes will accumulate in this area. So we call it the accumulation area. And then if we apply the positive voltage in the gate, because of this substrate is p-type substrate, so the plus charge will be pull each other, so there will be a depletion area. But if we applied more stronger high voltage in the gate, the minor carrier of the p-type substrate will be goes up to this area, and it causes a channel, so it causes an inversion area. And this figure is the figure of MOSFET. It is the source and drain part is added in the MOSFET. So if we apply the voltage in the drain, I always said in the inversion area, the channel is made. So if we apply the voltage, the electrons will be moved to drain from source. So we can think, if we apply the strong voltage in the gate, there will be a lot of electrons will be made the pass, and if we apply the strong voltage in the drain, the more electrons can be move, so it makes a current. But look at this figure. In this figure, we can show there in this part the amount of current is getting large, but this area, the amount of current is constant. We call this area is linear area, and this area is called saturation area. When VDS is larger than VGS minus threshold voltage, no more current is getting larger. So I already talked about what is doping and N-type and P-type, and the MOSFET has this MOSFET operation has this MOSFET's operation is divided into this region, and this is the MOSFET. The NMOS and PMOS is divided by what we doped the substrate. And I already talked about the saturation area and linear area. And last week I already talked about the MOSFET transistors, the function that it can operate like amplifier and switch. So this is end of week 2. Thank you.